Hello. Today I'll be speaking about the big benefits of small data. My name is Christopher Lozinski. I live in Katowice, Poland, and you can find the slides at forestwiki.com/slides. forestwiki.com/slides. So the first question is, what is small data? If you take a look at Wikipedia, they have a wonderful definition. The term big data is about machines and small data is about people, by Alan Bonde. And so in fact, in this application, every single piece of data was hand curated by a human, and the different parts of the data were looked at by literally hundreds of thousands of people during the most recent presidential elections. What is the application? Well, this is the Green Party Maps application. At first, it looks like a map, but really it's a data model of a large distributed organization. You can visit the website at map.howie2020.tech. Let me repeat that. map.howie2020.tech. So what are we going to talk about today? We're going to start about discussing why we use hierarchy for small data. We'll take a tour of the Green Party Maps application. I'll tell you a little bit more about the hierarchical software model. And then we're going to get to the core of the talk, what the user's experience was with it, what we learned about small data, and some concluding remarks. So why do we use hierarchy for small data? Well, the basic principle in human factors is that there should be no more than about 7 items in a category. So if you have more than that, you end up with a tree, a hierarchy. And this is why we organize organizations, and we have hierarchical charts for organizations. Small data is often hierarchical. The largest small data set that I know of, well, there's the Library of Congress, but the largest one that people use a lot is the awesome data sets on GitHub. Here we have the awesome data science sets, and they're organized as a tree. It's much easier for people to use and understand them that way. And more recently, JSON schema has become very big. If we take a look at this on the left-hand column, we have a JSON definition of a schema. On the second column, we can generate a user interface in JavaScript on the client, and that using a number of different client libraries. And then that data is validated on the client against the schema, so you get really fast interaction for the user. And then you can submit that JSON to a server. You can generate the JSON, you can submit it to a server, and in column 4, we validate it on the server just to make sure that nobody does anything tricky. And then finally, we can update the database. So JSON schema is a tree, and it defines a tree of JSON for the data. Very powerful, growing in popularity. And actually, I will show you a form that was generated using JSON, and on the right-hand side, you can see a little piece of the very rich and large JSON schema for this application. And what's the application? Well, this is the Green Party Maps application. So let's take a look at the application, and I need to switch you to, there we go. So here we have the map of the US Green Party. Again, it's at map.howie2020.tech. And we have filters. So here we can see just the candidates. Here we can see the parties and the candidates. Here we can hide the candidates. It's organized as a tree. You can think of it as a file system, but really it's run on an object-oriented database written in Python, optimized in C. So let's click into California. Here you can see this year's suite of candidates. Here you can see a map of California. Here you can see detailed contact information for California, and there's lists of politicians and parties you can click into. So let's click into this. Let's zoom in a little bit here. Let's see, I think I need the local parties on. And here we can see Green Party of Santa Clara. Okay, so here at the Santa Clara level, you only see the candidates that you can vote for at the local level. And so in this case, it's the president, vice president, and Jake Tonkel, who's actually in San Jose. And again, we can see the contact information. And we can continue to drill down into this tree. So let's click into Jake Tonkel. Every page has a logo, But what Jake Tonkel for his logo is he's added his picture. And while it's written in Python, we have class inheritance, but in this case, we also have data inheritance. So any branch of the tree inherits, does data inheritance, what we used to call acquisition of its parent logo. And you'll see that the children of this all have his image. And again, you can see all the contact information for him, and you can see that his information. We also have a virtual meeting. So let's click into his virtual meeting. And so this is a different content type. It's a virtual meeting. And you can see that he's got 2 videos here. And so we're clicking to the videos. And in the upper hand left-hand corner, you can see where we are in the tree. We'll come back and discuss that again in a moment on the slides. You can see it's a video. This is, again, a different content type. But maybe you're not happy with the content here and you want to edit it. So it's a content management system. We can add some lorem ipsum. And it's a typical WYSIWYG editor. You can do italic and bold and strike through and different font sizes. And you can then save all of that and you can view it. And there you have all of those changes. But whoops, of course, this is the production website. So we really don't want to be making those changes to the production website. But it's based on a good content management system. The Forest Wiki is the first cousin to Plone. And so we can take a look at the history and we can restore it. And now when we view it, all is back to normal. So let's go back up. I'll show you 2 more things. One is that you have to, there's a large number of contributors, an increasing number of contributors here. And one of the things is we need to keep an eye on all of them. So it's actually a management view where we can see who's made which changes. And here's some changes that people have submitted, but we need to approve them. Okay, that needs to, I'll have to check that after this. And if we go back, and we can also see here, there's actually a news site. So it's a tree and it's being updated all the time. And so the end users can look at any branch of the tree and see the news for that site. So that's a really important feature too. Okay, at this point, we are going to return to the talk. So we saw that this was not just a map, it's also a directory because every node in the tree has contact information. You can take any branch of the tree and build a website out of it. I'll show you that later. You can see its news. And in the Santa Clara, we saw that there were the recommended voting lists. They could endorse third-party candidates, and so that make it easier for people to know how to vote. And it's a content management system. There's also a Discord server connection I didn't show you. Okay, so having seen the application, let's take a look at the hierarchical model. The Forest Wiki it's built on the Forest Wiki. That's a first cousin to Plone. And a lot of these ideas come from the Plone community. Some build on what's possible in Plone. So the first thing is we have to traverse it. We have a tree of objects and we have to traverse to the object. So we start on the root, and then we traverse to the map. And from there we can traverse to map/California, map California, Santa Clara. But the problem is when you rearrange this tree, your URLs are going to change. And so that's not very good. So we also have something called canonical URLs. So the root is again /, or we can call it root. 1 level down is map. 2 levels down with canonical URLs, you can just reach them directly using /California or directly with /Santa Clara, and further down directly with Jake Tonkel. So this is a second path from the root to a particular node, and that really makes this a graph database. This is running on an object graph database. But for simplicity for the end users, they generally don't see that it's a graph database. They just see that it's a hierarchical database. Makes it much easier for users to manage, understand. And then a lot of this is the Plone is code taken from Pyramid. And so you traverse to an object either by traversing all the paths or by using canonical URLs, and then you have views on those objects. So here we have one view, which is a map. Here we have the edit view. Here we have the newest items. This is news view. Here we have that management view that I showed you. And then there are a whole bunch more views for manipulating the tree. On the left-hand side, you have for managing the tree, and on the right-hand side for adding different content types to the tree. So those are views on objects. Let's talk a little bit more about the hierarchical model of the Green Party. So in this case, we have a root. We didn't even visit it. At the second level down, second row, you have the Green Party of the US. And the only candidates who are present at that level were the president and the VP candidates, because anybody in the country can vote for them. At the third level of the tree, you have the state party, and we store the governors and senators there because anybody in that state can vote for them, but nobody in any of the other states should really see them. And then finally, we have local party counties where all other candidates are stored, so that only people who can actually vote for those candidates end up seeing them. Okay, so that's the basic hierarchical model. Of course, it's way more complex than that, but that's just to give you the core concepts. And then now with this JSON schema, when you come to an individual like Jake Tonkel, you see that he actually has a tree of data underneath him. So you can see the tabs. There's introduction, connect, candidate info, elected official, party officer, volunteer. Those are each different branches of the tree. Not everybody has every branch, but connect, pretty much everyone has this branch of the tree I'll show you, which is the connect, which is basically the contact information for that individual. So that's all based using JSON schema. I really love JSON schema. And the other thing is that because it's a tree, you can take any branch of the tree and generate an instant website. So on the right-hand side, you can see one of the instant websites for candidates. And so next year, as the new politicians arrive and they're not sure if they want to run or not, we say, listen, just fill out a form. Boom, you have your first pass of your website. So that's really makes it easier for them to get started. Okay, but there's a lot more to this data model. There are really a lot of different classes that it went into this. So let's take a look. First column, the basic content types from the Forest Wiki. You have a WYSIWYG page with the WYSIWYG editor, title and brief description of the WYSIWYG text. For the data scientists, there's also markdown pages where you can edit the content using markdown, and then it generates the HTML, caches that for you. We have links, the tree of links, YouTube videos you saw, online events you saw, online organization you didn't saw, logos you saw, banners I don't think you saw. We can also add files. So just basic content types for any file management system. Then there are a whole suite of types for managing maps. Originally, I worked on Google Maps. I don't like that they track everybody. Now OpenStreetMaps, I suspect they also track everybody, Mapbox. And then remember the GeoJSON map? So the outline of every state, you can click into a state. And so that's using GeoJSON data. We have the organizations. Those would be the state parties, the local parties, and the caucuses, like the Young Eco-Socialists or the LGBTQ caucus. Politicians, really they're people. Can either be politicians for state office, local office, or they can be Green Party politicians. And then several others, map organization. States like California are both an organization and a map. So I use Python's multiple inheritance to create map organizations. And then a whole bunch of templates. So what you'd like to do is allow the end users to do some customization of the look and feel. So for that, there are a bunch of templates they can use in the browser, both for HTML. ACE HTML is the ACE editor, allows you to do technical editing of HTML. Secure HTML, some of those reports that you saw are actually secure. So only those people with authorization can see what the progress is. CSS, typically on a file system, CSS don't have children, but here I do a tree of CSS objects, so it gets served as a single CSS, but then you edit each CSS piece as a separate chunk. That's very nice. And similarly, JavaScript folders. In a moment, I'll show you the B-tree images and thumbnails, very powerful. Pug is like Haml, I'll show you that in a moment also. And then I did a whole bunch of stuff with Python in the browser, but people don't seem as interested in that. Okay, so here are the B-tree images. One of the things I have to do is not only images, but thumbnails of those images. And I'm not a graphics designer, so I didn't know how big they should be. And there are a lot of thumbnails, and I didn't want to have to go and regenerate them every time. And so what I did is now here an image, unlike on a file system, an image can have child images. So here we have the map of the US, and you can see the different child images of different sizes. So if I access /social media image, which you need for Twitter or Facebook, then you get the full image. But for the thumbnails, you can just do /400 wide, /200 wide, /100 wide, and it returns the thumbnail of that size. That saves bandwidth. And even if that thumbnail doesn't exist, it creates that thumbnail and stores it. And there's a little bit of security on that, so that, okay, because you don't want to be storing a million different thumbnails. Okay, so that was B-tree image, a great example of using an object database instead of a file system. And then pug templating, this is like Haml. On the right-hand side, you can see some HTML. On the left-hand side, you can see pug. Now, HTML page is actually a tree. And of course, particularly for Bootstrap menu bars, those trees get very complex, and I get totally lost. So what I do with those is I edit them in pug. It's uses indentation to find hierarchy, just like Python does. And so it's really much easier to edit pug than it is to edit HTML, particularly for complex Bootstrap menus. And so, in fact, the end users can customize their Bootstrap menus, their menus if they want to for their particular branch of the tree. Okay, so remember I showed you a video page for Jake Tonkel with his video, and in the upper left-hand corner, we had the hierarchy. So let's take a closer look at that. This is the hierarchy. And here we have the top level of the tree. And on the right-hand side, I'm going to show you roughly how large the tree can be at this level. So Howie Hawkins map server, and maybe there's 7 categories at the root. On the right side, I'm not going to focus in on the right side, but you can just keep an eye on it to keep an estimate of how big the tree is. Green Party map at directory, well, that takes us up to 50 states, so maybe 350 at that level. Green Party of California, they had a lot of content, but maybe on average 7 items at this level of the tree. Green Party of Santa Clara, maybe less, but still on average, maybe 7 items, maybe 5 items in this level of the tree. Jake Tonkel, the candidate, he had one virtual meetup. In reality, he'd have a lot more. They just weren't tracked in the database yet. And then his particular videos. So once you have 1, 2, 3, 7 levels deep, say you have about 7 items in every category, some have more, some have less, you end up with about 5 million items in this tree. And that's a huge amount. You can have a large number of people working on it, but you don't get lost. You have a good sense of where you are, but you have to make sure that they don't step on each other's toes. So if we have a very rich security model, it's a hierarchical security model. And so at any branch of the tree, you can assign editors. So at the national branch, they can create a California branch, assign somebody in California to be the editor. They can create a Santa Clara branch, assign somebody in Santa Clara. They can create Jake Tonkel, assign somebody in Jake Tonkel, and Jake Tonkel can create some videos and some events and put somebody else in charge of that. So you have a rich security model that works for very large distributed organizations. Okay, so that's the end of the hierarchical model that we use. Let's talk about the core of this talk, really the users and what the impact was on the users. So the first thing is that the small data is hand curated. We crawled whatever data we could, but actually all the data we crawled was also hand curated. And so here's our data curation team, and maybe there are 5 of us who did most of the work. And then a lot of people helped on their individual states, and then the 5 of us filled in the other states. It's really useful. So you remember Santa Clara, we had all the contact information. Here we have the contact information for all of the local parties, all of the candidates, all of the, very shortly, all of the elected officials. Very, very useful information. And the small data is really loved. So I asked my boss what he thought about the project, Alex Noy project, and he said, it's ecstatic. Holly Hart, the Green Party US CCC co-chair coordinated campaign committee, CCC really likes this. Lots of other people really love what we're doing. And boy, are they upset if we get it wrong. We got a message from one state Green Party that we'd added a candidate who they had not endorsed. Oh, they were upset. Okay, no problem. We removed the candidate. Oh man, that candidate was even more upset about getting removed. So people really get upset if we get this data wrong. In fact, right now, the entire Green Party is voting, the senior committee is voting on exactly what the policy is for what data is to be included and what data is not to be included. And of course, small data is very labor intensive. It's all this hand curation, a lot of discussion. And so you need a lot of volunteers. Either that or you can generate a lot of good jobs for people. And then small data has to be managed because we've got a whole team of people entering it. So on the left-hand side, you can see our management screen. We tracked all the different states and when the state was completed. And then one of the states had a problem, so we marked it as incomplete, and then the appropriate person went and fixed that state. And then the project manager would track every state and do some quality control on each state as it was completed. And then, but you also have to keep an eye on things, and particularly as more and more users are using it. So we had this management view. And in this management view, you can see all the changes to any particular branch of the tree. So that's really important. You have to make sure that maybe somebody's adding spam to a branch, just kind of be able to audit transactions. Okay, so that's the user experience. Let's talk about the small data itself. So the first thing is that small data is very low noise. The data is hand curated. That gets rid of most of the problems. Users give feedback. A lot of users give feedback if they spotted something wrong with their data. And then the other thing you want to do is have views with higher signal to noise ratio. So on the left-hand side, you can see the map of California and of New York. So for those state websites, they can just link to the state map. And so that's really much less noise. The other thing we're starting to do is, you saw the map legend across the top of the map. So there initially we selected for parties or candidates, and we're doing much more detailed. So on the top level, you can see local parties, candidates awaiting results, election victories, lost elections, party officers. And down below, you can see actually the next version, which we haven't installed yet, is where there's actually a much richer search filter with, you can either say which organizations you want to see, which kind of politicians, and we're starting to include not only Green Party politicians, but also socialists and maybe independents, certainly independents, and maybe also progressives. So that'll make it a much more useful, and each of those there's a link. So for example, the Young Socialists caucus within the Green Party will be able to link to a particular URL, and it'll only show all the caucuses, all the young eco-socialist caucuses all across the United States. So then the map, you get a whole suite of maps for different organizations. So by reducing the noise, you make it much more useful to all of the different viewers. And then small data, maybe many people don't even recognize this. They called this a floptical. It would only take about 20 megabytes. Not counting the images, the core data would fit on half a floptical. So the data is really quite small. And it's really fast. For those who are international, they may not recognize this as the Roadrunner, who's so fast that Wile E. Coyote could never catch her. But because everything can be cached in memory, the application runs really quickly. And furthermore, for the anonymous user, everything is cached behind a caching web server, currently Caddy, shortly Nginx. Okay, and so because it's so small, we don't need a big server farm. We only take a fraction of the server, a virtual private server. During the election, it was 4 gigabytes of RAM, 80 gigabytes of drive, about $20 a month. I think after the election, the traffic's going to go way down, $20, maybe even $5 a month will be sufficient. Linode does a brilliant job. A lot of people like DigitalOcean. And so because it takes a much less of a server, it consumes much less energy. There's a huge problem with climate change. It's not just the polar bears are hurting, millions of people all around the world are already climate refugees, wars, water wars. It's just going to get uglier very fast. How much energy does the internet consume? Well, I don't know. I see different numbers. I don't think it's as high as 10%, although I've seen that claim. I don't think that the large internet giants really want to release how much energy they consume. And even if they move to renewable, it still takes a huge amount of energy to create all of those renewable energy resources. So whatever we can do to reduce energy consumption, we really should do, and small data is a great way to do that. And once you're being efficient, you may as well have small code. So not counting the 55 third-party libraries, which I don't have to touch, there's only 12K lines of Python code. So massive code reuse. And the whole thing was done by one developer. Oh, maybe my view from home is not quite that nice. And remember, it's not just a single application, it's multiple applications. It's the national map, state maps, it's directories, instant backup websites, news sites, a recommended voting list, there's a content management system, there's a Discord. So a huge amount of functionality can be achieved by good software design, software reuse. Okay, so that ends the section on the small data. A few remaining remarks on data science. So the maps were really useful. My boss spent a huge amount of time looking at them. Not quite sure why. His boss said that he never understood the Illinois Green Party until he really spent time with the maps. We did some analysis of which state parties are the most active. The most interesting analysis was 2 different spreadsheets I copied and imported, and they were off. And it turns out that because of that, we realized that different people have different policies as to who is a Green Party and who is not a Green Party. And so now we're developing a policy document as to who is included as an official Green Party member on the map and who is a non-official Green Party member on the map. Okay, so when do you use small data? When do you want to avoid big data? During global warming, wherever possible, please use small data. And we're in a global warming period. On a niche topic, so all the awesome lists on GitHub, Green Party United States, soon global Green Parties, they're all niche topics. If you're doing Google for the whole internet, it's going to be hard to take this approach. It's particularly good at indexing the web. There's so many pages. Which ones do you want access to? Use a human to curate them, link to the important ones. Great. High noise environments, there's also a lot of spam on the web. So for very high noise environments, human curation is great for eliminating noise. So if you have a situation where machine learning doesn't work, try the small data approach. And also, I think it really leads to a better user experience. The data is so high quality, there's such a good signal to noise ratio. I think users really love this. Let's see how much time I have remaining to discuss the software tools I used. 2 minutes left, not much. I guess the big thing is I'm increasingly not using the file system, and I am using an object database to store like all the templates. And so the file system, the hierarchical file system, started off in Multics in 1965. Actually, I used Multics, but it's really ancient. So files don't have children, and directories, well, they don't have attributes, they don't have methods, and you can't send them a message. So using object database wherever possible, I think it was a huge, huge boost to the productivity. Lots of other great tools here. Anyhow, ask me questions later if you want any questions about the software tools. So finally, some links. You can see the website at map.howie2020.tech. forestwiki.com/slides will get you all the slides, and pythonlinks.info/contact to contact me. And I am starting to do these classes on JSON schema. If you're interested in a free class for your local meetup, please contact me. Thank you.